Hello, this is Mr. Wynn, and this video is over solving rational inequalities. So, to solve a rational inequality, follow the steps below. Step 1, solve the related rational equation, note all solutions and restrictions. So when I say solve the related rational equation, related means solve the equation itself. So just change the inequality sign to an equal sign and solve this. When we're solving fractions, rationals, we need to find LCDs. So I'll put this over 1. For the LCD, we need every unique denominator. We need a x plus 2, one of those. We also need a 1, but 1's the only number you don't have to show. I'll save some time for my restriction now. I'll say x cannot equal negative 2. Alright, I'm going to fix each fraction. The first fraction is not missing anything, but the second one is missing x plus 2 over x plus 2. Alright, once you do that, the first fraction is just x over the LCD. And the second fraction is going to be 0 times this over the LCD. Now we get rid of both fractions by multiplying each side by the denominator, LCD. So LCD's crossed out, we get x equals 0 times all that is just 0. That's my solution. Now unlike a rational equation where you have to make sure the solutions are not in the restrictions, we have to do step 2, put all solutions and restrictions on a number line, because we're going to find a range of values. So on a number line, I draw it, goes forever. We have two numbers, we have negative 2, and we have 0. We're going to do a test point for each region. So really, we have all the numbers left of negative 2, the numbers between negative 2 and 0, and to the right of 0. You pick whatever you want. So maybe I pick negative 3. If I try negative 3, let's see if it works or not in the original problem. Negative 3 over negative 3 plus 2 is greater than 0. That's negative 3 over negative 1 is greater than 0. That is positive 3 is greater than 0. That is true. So this is true. Check the next area. Between negative 2 and 0, let's try negative 1. So I'll do down here. Negative 1 over negative 1 plus 2 is supposed to be greater than 0. That's negative 1 over positive 1 is greater than 0. That's negative 1 is greater than 0. That's false. That did not work. Then I'll try another area, something on the right side. Let's try 1. And you do any number. You can do 5, you can do 10, you can do 1,000. I'll show you a trick for that later. But I'll do down here. So 1 over 1 plus 2 is supposed to be greater than 0. That's 1 over 3 is greater than 0. That is true. Oh, we have two true areas. Finally, write your answer. You're probably going to need union symbols. And also, just so you know, if the inequality has an equal sign, so this did not have an equal sign because it's just a greater than sign. But if it's closed, we need to count the solutions, but restrictions are always open. So our final answer, and I'll write it up here, the left side of negative 2 is good. So we're going to say from negative infinity all the way to negative 2, open. Then or, so union, you skip the negative 2 to 0, but at 0 to infinity, that works too. So 0 to infinity. That is the answer here. If you want the other direction, you can say x, the set of all x's, such that x is less than negative 2 or x is greater than 0. Your choice. Alright, now usually when I do a test point, I pick something extreme. For example, I would have picked on the right of 0, I probably would have picked 1,000 or 1,000,000. If you do that, the top of the fraction is positive, 1,000,000, the bottom fraction is 1,000,000 too, but that's really just 1,000,000. But it's positive by positive is positive, and a positive number is always greater than 0, so you can do a sign check. Alright, let's try a harder one. Solve the rational inequality, follow the steps below. So now we have multiple things. So again, first, solve the related equation. So I'll treat this like an equal sign, and I'm going to put a plus here and shoot this negative 1, because you know, get rid of how to add fractions, right? That's x over 3 plus negative 1 over x equals x plus 1 over 3. I'm going to find the LCD. I see a 3. I see 2 of them, but the most shows up once is 1 time, so I need a 3. Also, I see an x. And that's it. Restrictions, x cannot be 0. I'm going to fix each fraction. The first one is missing an x. Second one is missing a 3. The third one is missing an x. So now everything has 3x on bottom. Fix the top, call the bottom LCD. So the first thing is x squared. And then that'll be minus 3, because positive times negative 1 is negative 3, over LCD. Equals, I'm going to distribute this, so that'll be x squared plus x over LCD. Get rid of the denominator, I'm multiplying both sides by LCD. So that gives me x squared minus 3 equals x squared plus x. Subtract x squared from both sides, you get negative 3 equals x, and that is not in our restriction. Alright, so step 2, make the number line. Put every restriction, every answer on here. This one had negative 3 and 0. And there can be more sections, you'll see on the end of the problem. We're going to test something from each section. Alright, so I'm going to not use the original. Something on the left of negative 3. Let's try negative 4. Alright, so I'll do it like this. Negative 4 over 3 minus 1 over negative 4. That's really plus 1/4. It's supposed to be less than negative 4 plus 1 over 3. If I add the left side and I do common denominator, which would be 12. So we do this, so 4 over 4, 3 over 3. That will give me negative 12 over 12. No, sorry, negative 16 over 12. Plus 3 over 12. This is actually negative 3 over 3. So this is negative 13 over 12 is less than negative 1. And that is true, because negative 13 over 12 is actually a number smaller than negative 1. Because if I want to do common denominator here, I could say, oh, that's negative 12 over 12. Alright, so that is true. Translating between negative 3 and 0, I'm going to try negative 1. If I do negative 1, I'll do down here. Let me do this. So I tried a negative 4 here, that worked. I'm going to try negative 1. So negative 1 over 3, and then minus negative 1. Oh, 1 over negative 1, which will be plus 1. I'll save some time. Is less than 1 plus 1 is 2 over 3. So that is 2/3 is less than 2/3. That's false. Alright, now I'll try something over here. I'll try positive 1. So positive 1/3 minus 1 is supposed to be less than 2 over 3. That's negative 2/3 is less than 2/3. That is true. Alright, write on my answer. So it's to the left of negative 3. So negative infinity all the way to negative 3. Open. Union. And to the right of 0. So that's 0 to infinity. Alright, so anything in those will make the original equation true. Alright, one more. There's a way to make the overall process easier, and that is step 1, rearrange the original inequality to make one side 0. If one side 0, it's a lot easier to check using signs of values, which I'll get into in a second. Step 2, if there are multiple terms, simplify them to one big fraction. Combine it. You want one single term. Then 3, roots come from the numerator. Restrictions come from the denominator. So technically, if you think about this, if I multiply both sides by x minus 1, this disappears. So all we really have is x minus 3 times x plus 2 is equal to 0. Because the bottoms don't really matter here. So with that, we just say the top equals 0. You get your two answers. X equals positive 3, x equals negative 2. Then you look at our restrictions from the denominator only. That we cannot divide by 0. So we say x cannot be positive 1. Alright, so that was fast to find everything. Again, once you put in the correct format. Now we still draw the number line. I put everything on here. This one there's more. So put them in correct order. So negative 2 is the smallest, followed by positive 1, followed by positive 3. we're going to test something in each area. And here's how I'll do the test. Let's test negative 10. All right, well, I plug negative 10 for x right here, right here, right here. You could say, oh, that's negative 13 times negative 8 over negative 11. But I'm doing the signs instead of the values. So negative 10 minus a number gives me a negative. And then negative 10 plus a number, plus 2, which is smaller, is still a negative. And over negative 10 minus a number is still negative. So we do that. This, a negative times a negative, is a positive. That's really a positive over a negative, which overall turns into a negative. So the left side is negative. Is a negative number less than or equal to 0? The answer is yes, that's true. So this is good. I'll pick something between negative 2 and 1. Let's try 0. If I plug in 0 for all the x's, the first thing is negative 3, which is a negative. Then positive 2, which is positive, over negative 1. Well, a negative by negative is a positive. A positive times a positive is a positive. Is a positive less than or equal to 0? Well, that's false. So that did not work. Then I'll try something over here. Let's try 1,000. Oh, there's 4 sections. Oops. All right. We have to try something between 1 and 3. So let's try positive 2. All right. If I try positive 2 for all the x's, let's see. So right here, right here, right here. 2 minus 3 is negative 1, which is negative. 2 plus 2 is positive 4. 2 minus 1 is positive. All right, well, positive by positive is still positive, and then a negative divided by a positive is a negative. Is a negative number less than or equal to 0? The answer is yes, true. So that's good. So parentheses around these. All right, last section. Let's try something bigger than 3. Like I was trying to do before, I'll try 1,000. All right, if I try 1,000, the first number is positive. The second number is positive. The third number on bottom is also positive. When you fix all that, that's going to give us a positive number. Is a positive less than or equal to 0? That's false, so this fails. So here, my final answer is left of negative 2. So negative infinity. Oh, by the way, let's see. 3 and negative 2 are closed. So negative infinity all the way to negative 2, that is closed. Union, I skip negative 2 to 1, but 1 to 3 is our next section. 1 is a restriction, so you can't have it closed. And then 3 is a solution, so that is closed. All right, so that's what I mean in red. If it's a root, if it's a solution, because this right here has an equal sign, this little part right here, that means the roots count as closed. Only the restrictions are open. So this is open, this is closed, you can count that. This is closed if you can count that. All right, that's it for the video. Make sure you ask some questions, watch the live sessions. Thanks for watching. See you soon. Bye.